Let's talk about Kubernetes. As you can see on the screen, Kubernetes is a container orchestration platform used to deploy, manage, scale, and heal the containerized applications automatically. ये पढ़ने में थोड़ा सा टफ लग रहा है, थोड़े वर्डिंग्स भी आपको शायद समझ में ना आए, इसलिए आज हम इसको एकदम बेसिक से समझेंगे कि Kubernetes होता क्या है, इसके कंपोनेंट्स क्या क्या हैं, इसको यूज़ कैसे करते हैं, इसका बेसिक आर्किटेक्चर क्या है, एंड देन इन द लास्ट वी आर गोइंग टू डिप्लॉय अ लोकल क्लस्टर और उसके ऊपर हम सारे कमांड्स रन करेंगे और हम सब देखेंगे कि ये डिप्लॉय कमांड क्या होता है, हाउ टू स्केल और हील कैसे होती है एप्लीकेशंस ऑटोमेटिकली एंड ऑल ऑफ दैट. व्हाई Kubernetes? नाउ दिस इज़ अ वेरी गुड क्वेश्चन. हमें Kubernetes की ज़रूरत क्यों पड़ी? देखिए एक्चुअली होता क्या है, आप किसी भी आपको मशीन में आपकी कोई एप्लीकेशन रन करनी है, आप उसमें SSH करते हैं एंड देन यू स्टार्ट द एप्लीकेशन. Kubernetes क्या करता है? ये भी वही काम करता है, बट इट हैज़ मेनी गुड फीचर्स. जब एप्लीकेशन आपकी क्रैश हो जाएगी तो आपको मैनुअली वापस लॉग इन करना पड़ेगा उस मशीन में और आपको एप्लीकेशन चलानी पड़ेगी. Kubernetes वो काम आपके लिए ऑटोमेटिक करता है. इट हैज़ अ सेल्फ हीलिंग फीचर. लोड बैलेंसिंग. नाउ व्हाट हैपेंस, आपके पास एक एप्लीकेशन आपने चला दी. नाउ देयर इज अ लॉट ऑफ लोड ऑन दैट एप्लीकेशन एंड यू डोंट नो हाउ टू हैंडल दैट. With Kubernetes, you get an automatic option that it can load balance your applications onto different nodes. When I say nodes, nodes is nothing but different machines, different VMs, different Linux machines, for example. It supports rolling updates and rollbacks. अगर कोई प्रॉब्लम आती है then you can do a rollback or a rolling update like that. It works everywhere. Cloud पे, on-prem पे and local environment. Today we are going to see a demo on local cluster. कैसे Kubernetes काम करता है. Core Kubernetes components. Let's read them. It's a very important thing. Pod. Pod is the smallest deployable unit containing one or more containers. So when I say container, so container means your application. So pod is an environment to that application. Second is deployment. What exactly do we do with the Kubernetes? When we run any command, so we don't do like create a pod or create a container. What we do is we do create a deployment. Now that deployment manages all the pods and the desired state. चिंता मत करिए, हम इस सब को थ्रू एन एग्जाम्पल देखेंगे ऑन आर लोकल क्लस्टर. Replica set ensures that required number of pods are running. When we say required number of pods, let's for now assume required number of application instances are running. Service. It exposes pods and provide load balancing. Basically इसको आप सिंपल लैंग्वेज में समझिए कि आपका जो पॉड चल रहा है, आपका जो कंटेनर चल रहा है, आपकी जो एप्लीकेशन चल रही है, दैट इज इन अ कंटेनराइज्ड एनवायरनमेंट. आप उसको डायरेक्टली एक्सेस नहीं कर सकते. So what service does is it lets you access your application which is running inside the container. इसको भी हम एग्जाम्पल से देखेंगे. Node you can just understand that it's just a machine, a VM, a physical machine or a virtual machine which is running your Kubernetes cluster. Control plane. So control plane manages your cluster. कंट्रोल प्लेन के अंदर क्या क्या प्रोसेस होते हैं वो हम सब देखेंगे. उसके अंदर एक API सर्वर होता है, शेड्यूलर होता है, एक की वैल्यू पेयर डेटाबेस होता है एंड ऑल ऑफ दोस थिंग्स. बेसिक Kubernetes आर्किटेक्चर. जैसा कि आप देख रहे हैं कि इसके अंदर कंट्रोल प्लेन होता है और वर्कर नोड्स होती है. सो ये चीज़ें होती क्या है, करती क्या है. कंट्रोल प्लेन के अंदर हमारे पास 4 प्रोसेसेस होते हैं: शेड्यूलर, कंट्रोलर्स, HCDMN एंड API सर्वर. और वर्कर नोड में हमारे पास होता है क्यूबलेट्स, kube proxy and pods. Now pod, they'll contain your applications. Let's see what they do actually. Master node. Now this is your control plane. जैसा कि हमने देखा इसमें 4 प्रोसेसेस होते हैं. API server. Everything talks to the API server. आप kubectl कमांड रन करेंगे to manage the cluster. We'll see how it works. And API server के पास रिक्वेस्ट जाती है and then it responds back. Scheduler. शेड्यूलर डिसाइड करता है कि which worker node runs a pod. Now worker node, what is a worker node? Worker node is just a machine, a VM, which runs your application. Controller manager. It ensures that the desired state is maintained. For example, if a pod dies, it recreates it. ये भी हम देखेंगे, हम एक pod को delete करेंगे and we are going to see that the pod comes back again. HDMN. Now HDMN is a key value database. इसके अंदर आपके क्लस्टर की सारी इंफॉर्मेशन होती है कि क्लस्टर की स्टेट क्या है, उसका कॉन्फ़िगरेशन क्या है, मेटा डेटा क्या है, एंड एवरीथिंग. वर्कर नोड. इन अ वेरी सिंपल लैंग्वेज, वर्कर नोड इज योर वीएम, एक लिनक्स मशीन जहां पे आपकी एप्लीकेशन रन कर रही है. उसमें 4 मेन प्रोसेस होते हैं. पहला क्यूबलेट. क्यूबलेट क्या करता है? ये एक छोटा सा एजेंट है दैट टॉक्स टू द मास्टर एंड मेक श्योर द कंटेनर्स आर रनिंग एज एक्सपेक्टेड. सेकेंड होता है आपका कंटेनर रन टाइम. दिस इज बेसिकली योर डॉकर और कंटेनर एंड इट रन्स योर कंटेनर. थर्ड है आपका क्यूब प्रॉक्सी. नाउ इट हैंडल्स द नेटवर्किंग इनसाइड द क्लस्टर, विच मीन्स आपके क्लस्टर के अंदर आपने एक कंटेनर बनाया जिसके अंदर आपकी एप्लीकेशन रन कर रही है. नाउ द पीपल इन द आउटसाइड वर्ल्ड, इन द पब्लिक वर्ल्ड, दे कैन नॉट एक्सेस योर एप्लीकेशन. सो it is done using kube proxy. And number 4, pods. As we already know, it's a smallest deployable unit and it can contain one or more containers. Now we'll see the Kubernetes flow. What happens? Everything runs from that kubectl command. Kubectl commands, when you call that, it goes and contacts Kubernetes API server. Kubernetes API server, it contacts etcd and store the desired state. After that, the request goes to the scheduler. Now scheduler selects on which VM the application should run. Then on that particular VM, the kubelet is running that receives the instruction that go and run this application. Kubelet, with the help of container runtime, starts that container. Now that container is nothing but your application. All right, let's move to the demo. But before that, let's see what all things we need as part of the demo. First, you have to download kubectl. This is a CLI utility which is used to communicate to the Kubernetes server. Second is minikube. This is another utility which helps you to run the Kubernetes cluster on your local machine. Third is the Docker desktop. So Docker desktop is an environment where you can see all your running containers, and you can log into the containers and see their state and everything. So we'll see them step by step. All right, so we have kubectl and minikube downloaded, and you can see their version, kubectl version and minikube version. This is how the Docker desktop looks like. So you can see you have containers, you can have images, you can have logs, you can have volumes and all of these things. So basically consider this as a Docker deployment on your local machine. But for now, we are using Docker desktop. Okay, let's run through some commands and see how the containers work and how Kubernetes work. The first command is minikube start. What does minikube start does? It actually starts a local cluster in the Docker by default desktop. As you can see, minikube start is creating a Docker container which is by default, and it creates a container which runs Kubernetes. Let's go to Docker desktop. So you can see here a container with the name minikube is getting started. And now it has prepared Kubernetes on the container and all is done. Let's go into the container. So here we are, this is the container, and then if you go here, let's go to exec. Exec basically gives you a shell into the container. Now what we can do here is, for example, we see what all containers are installed. We do a docker ps and we see a lot of containers which are already installed by the minikube. This seems familiar. Kube API server, the scheduler, the etcd, the controller, and you have core DNS and what else? Yeah, all those things. Now, if you remember, these are the components of a Kubernetes cluster. Minikube has set up a machine for us, and inside that machine, it has created a Kubernetes cluster using Docker. As simple as that, which means this is a machine, we are here, and inside that Kubernetes cluster is running. Let's see another command, minikube status. It tells you the control plane is running, the host is running, kubelet is running, API server and the kube config are all configured. That we can see from the docker ps command itself directly inside the container. Now let's see what all we have. Kubectl get pods. There are no default pods right now. Now pod, as I told you, is an environment in which your application will run. अभी हमारे पास कोई भी application नहीं है, इसलिए there are no pods right now. Let's see if we have any deployments. Obviously we have nothing, so this shall also give you there are no deployments, there are no resources found. Now the most important command here is create deployment. What it's going to do is it creates a deployment with the name my first web app and hyphen hyphen image equal to nginx. It's going to go to Docker Hub and download that image and install it on our container. Before we run this command, let's see what's there in the container as part of nginx. ps hyphen ef grep for nginx. Do we have? No, we don't have anything for nginx. Now let's run this command. It says the deployment has been created. We can see get deployments. It says 0 by 1. It's going to come up soon. Not yet. All right, it's ready now. Let's go to our container and see if we have anything with respect to nginx. Okay, we have nginx running now on our container. Let's go to next commands and see, for example, we want to expose this nginx to the outside world. Right now the nginx server is running inside the container and we don't know how to access this. For that, we have this special command kubectl expose my deployment. Type is node port. Node port means on which port do you want to expose it, and hyphen hyphen port number. Now the service is exposed. It does not mean you can directly go and access on the browser. What you have to do is you have to do minikube service my first web app. What this command does is it creates a kind of a network between the containers and your host machine, and it starts a browser where you can access that container web app service. Let's do it. Okay, it started a web browser, and as you can see, nginx is running completely fine. Right now we have a single pod, which means this pod is running your application. If you notice, earlier we do not have any pod because we have not started a deployment. As soon as you start the deployment, we'll get a pod. Now you can also get deployments. This is your deployments. You can also get the RS, which is your desired current number of instances that you want, your replica sets. Let's talk about another command, but before that, let me tell you how Kubernetes automatically heal your application. Now let's see what happens when we delete a pod. kubectl delete pod, and the name of the pod you have to give, which is your my first web app. So it's deleting the pod, and now if you go back and check for pods, another pod is about to get ready, which means your nginx server has not died. It died, but a new pod has started it again. All right, let's go to Docker desktop. Here you can see the process ID of the nginx. Probably it's going to change now because it has died, it has been killed, and a new one has come up. Let's see. Right, so this is the healing mechanism of Kubernetes. If your pod died automatically, then it will start a new one. All right, let's look at these two commands. kubectl scale deployment my first web app replicas 3. What it means is we want the same deployment now to have 3 pods. 3 pod means each pod is running your nginx server. All right, very basic. kubectl get pods, you can see there are 3 pods running. Now we'll see load balancing. So we have seen minikube service my first web app. What it does is it basically allows your applications which are running inside the container to be accessible by the outside world. Okay, it opens a browser and it says welcome to nginx, but we don't know which nginx does it refer to. Is it from this pod 1 or pod 2 or pod 3? So let's do one thing. We'll change the basic HTML, the index.html file of all these nginx. So we are going to see what exactly the service has gone to and how the load balancing is happening. So we have three pods, and what I have done here is we went inside those pods and added our custom message. So this is the command to go inside the pod and get a shell. Now kubectl exec-it. Now this is very similar to Docker command. If we have this first pod and we want a shell, and inside the shell we have added hello from pod 1 into the index.html of nginx. Same we did for the pod 2 and pod 3. Now let's run the minikube service again. All right, you can see it shows hello from pod 2. Now it has randomly picked one of the three pods. If you refresh the page, it may go to pod 1 or pod 3, but due to some cache or timeouts, it is still on the pod 2. चलिए इसको हम थोड़ा फोर्स करते हैं and we delete pod 2. Let's see what happens then. Alright, we have deleted the pod, but as I told you earlier, Kubernetes will start the pod again. So if you do a kubectl get pods, you're going to see 3 pods again. But most important thing is, now pod 2, when it went down, the application did not went down. It moved to another pod. It was getting served from another nginx container. How? Let's see. We start minikube service first web app again, and you could see my hello from pod 1. All right, so that's how the load balancing works. I think that's enough for today's demo. It's a very basic understanding of Kubernetes. It's a very wide subject, although, but today we have covered a very basic architecture and the basic commands. Thank you for your time.